The function f is defined by f of x equals minus 8. That's our AO. It looks like an exponential function. 6 to the x, so r is 6, and then minus 4. So that's an offset on the y direction, down 4. What is the y-intercept of the graph of y equals f of x in the xy plane? So a y-intercept always occurs, and I don't care what kind of function it is, exponential or not, at x equals 0. So we want to find f of 0, and that equals minus 8 times 6 to the 0 power minus 4. Well, 6 to the 0 power, anything to the 0 power is 1 other than 0 to the 0, which is undefined. So now we can actually evaluate. F of 0 equals minus 8 times 1, which is minus 8, minus 4, which equals minus 12. So my y-intercept is going to be 0, comma, negative 12. Is there an answer like that? Yes, there is. A is the correct answer, 0, comma, negative 12. Number 15. Which of the following expressions is equivalent to quantity square root of 2q plus square root of 2r raised to the 2/3 power, where q and r are greater than 0? Okay, so this is probably going to be a little easier than it looks like. All I'm going to do here is I'm going to break apart my 2/3. I notice all my answer choices, well, all but one, are cube roots. So that's essentially the 1/3 power. Okay. So I could rearrange this in any way possible, but I want to rearrange it into my answers. So the form of my answer is to make it cube root, or of whatever it is going to be raised to the 1/3 power. So I'm going to rewrite this as square root of 2q plus the square root of 2r squared, and that whole thing is going to be raised to the 1/3 power, which is essentially my cube root. I'm just writing it as a rational exponent. Okay. So what is then the square root of 2q plus the square root of 2r squared? How would we evaluate that? Well, it's a perfect square. So a perfect square is square the first, that is square root of 2q squared, which is 2q, plus the double the product of the 2. So that's going to be root 2q times root 2r, which is root 2 times 2 times q times r, and we double that. And then I square the last. So square root of 2r squared is just plus 2r. This all is raised to the 1/3 power. Well, I can break out the square root of 2 times 2 to the square root of 4, which is 2. So really this becomes 2 times 2, or 4, square root of qr. Notice these allowed me to pull another 2, so 2 times 2, outside of the radical. Okay? So the rest is the same. 2q plus 4 root qr after simplifying, plus 2r, and I'm going to now express it in radical form, which is the cube root. Which answer choice is this? The cube root of 2q plus 4 root qr plus 2r. The correct answer is D for number 15. And again, it might help, rather than foiling out your perfect square, it helps to know the format of a perfect square. It's square the first, double the product of the 2, square the last. That helps compute it a good deal more quickly in many cases.